Hello, this is Almir. Another day for geeking out. Another episode of hanging out with a software engineer. Today's episode is going to be 7 things about working in Scrum teams and microservice architecture. So again, 7 things about working in Scrum teams and microservice architecture. So let's start with number 1. Just to give you a little bit of history, I've been in software engineering field for about 19 plus years, almost 20 years. I worked in monolithic applications. I worked in microservice architecture. So these 7 things that I'm going to describe is something directly from my experience. It is not some book that I read, some theoretical thing. It's directly related, or it's coming from practice. So let's start with number 1. Number 1, SAFe is not scaled if you get requirements in big bulks. For example, say a scaled agile framework is designed where you have a program team at the top. You have product managers, solutions architects, program manager. Requirements are coming in, and initially solutions architects would be reviewing those requirements and coming up with some high-level design and solution. Then those requirements would be broken down into smaller pieces, or basically epics become user stories that get distributed among one or many teams. This program team, as I mentioned, consists of only solutions architect, program manager, maybe a few other solutions architect, but it is a very light team. The teams down on the floor delivering, and all these teams delivering different implementations, each team could have 5 to 7 people. So the program team is a very light team. So if you get requirements in one big bulk, who becomes the bottleneck? It's the program team. Solutions architects have so much to analyze and break down into smaller pieces. So getting requirements in one big bulk, you're slowing down the program team, and then the delivery teams down on the floor implementing user stories, they will run out of work at some point. The right way to do it is get requirements flowing on a daily or weekly basis. Maybe at the program level they come more in a weekly or bi-weekly level. And if there's nothing to come in bi-weekly, maybe you can say every month, but you have to keep a cadence. If you have to keep yourself in check and do not fall in a trap where 6 months later you don't have any requirements, you cooked up all kinds of requirements and you're delivering 6 months of requirements in a single shot, and you're calling it scaled agile framework. But it is not scaled if the program team becomes the bottleneck, analyzing, coming up with a solution, breaking down. That takes time. So that's number 1. Number 2, microservices are micro if you follow the rule of single purpose or single responsibility microservices. If you're designing microservice architecture, it's easy to fall in the trap of old habits, where you may, for example, pick a relational database and you start designing the schema, and this schema ends up being 10-12 tables, and then you say you will wrap it around a microservice and expose the endpoints, but what you realize is that is not a microservice anymore. It has multiple responsibilities, it has multiple purposes, because all those tables are kind of different types of entities. If I want to design a RESTful route, there should be a single noun describing what that service does. For example, if I have a subscriptions microservice, what it does, it's used to create, update, delete, and get subscriptions. If I have customers microservice, it's used to get, create, delete, update customer record or customers records. But when you start designing your schema, and you end up with a half a dozen or a dozen tables, and now you're exposing the endpoints, it is not a single purpose microservice anymore. The way to force yourself designing a microservice, true microservices, is forcing yourself to write a definition of what that microservice does. For example, I may say that as a subscriptions microservice, I exist so that I can create, update, delete, and get subscription records. It's as simple as that. Now, if I say as a subscriptions microservice, I exist so I can get, post, put, delete, and do something else, or if a partner record comes in, I'm going to analyze something else and then do a get and a post. As soon as you get into definition of those ands, ors, and ifs in your definition, you realize that it's not a single purpose microservice anymore. So that was number 2. Stay true to your microservices and keep them micro. Number 3 is the story estimation by complexity. A lot of teams try to estimate stories by complexity. They walk into the room and the team says, let's estimate, and you analyze the details of the story, and then you put a complexity number on it. Stories that are estimated by complexity, yes, it tells you what complexity level each story is, but when you walk into a sprint planning meeting and you try to see how much you can fit into a sprint, a complexity number doesn't tell you much, because how do you know if you can handle 5 of 3-point complexity stories? How do you translate that into time? So that's something that, I mean, I'm sure there's debates in the agile methodology world about using virtual numbers versus absolute numbers. I'm more in that territory, in that side where I like to have ability to translate what that means in the real world. So using complexity for the story points is, in my opinion, not the right way to go. I prefer using some other ways of measuring stories, so that when I walk into the sprint planning meeting, I can easily say, let's add all these stories, use some type of a calculator or a tool, if a tool can do it for you, and that tool tells you basically, yeah, you're understaffed to handle these many stories, then you can remove stories in order to fit them in a single sprint. It should be a simple mathematical calculation instead of trying to use the complexity as a mechanism to see how much you can fit into a sprint. That's one way of doing it. I mean, if you're not using absolute numbers for your story points, and you're not using complexity, which I'm not recommending, there's always a way to go without using any story points. If you have a very small team, you can walk into a room and read the stories. Maybe you can give it some t-shirt sizing. T-shirt sizing is still better than complexity. T-shirt sizing tells me, oh yes, this is a small, medium, and large, and then when you walk into a sprint planning meeting, you can put all these stories on a whiteboard and put the t-shirt size next to it, and you can eyeball it, and you can still better determine which one of these you can fit, or what set of these stories you can fit into a sprint with product owner prioritizing these stories. So that was number 3. Number 4, watch for antipatterns in microservice architecture. In the past, when we were building monolithic applications, there was a concept of introducing an enterprise bus, and you would send the calls into that enterprise bus, and that guy abstracts everything. It abstracts the layers below it, or it does some type of a transformation so layers below can understand the data and process that data. In a microservice architecture, we have to try to stay away from this. Centralizing things it's an anti-pattern in a microservice world. If you have some type of a gateway, and that gateway you decide, let all my microservices use this type of a gateway or this type of a proxy, then you're realizing that you're centralizing things. What I mean by centralizing, you're running an instance or a family of instances or machines that are used to process this, and all microservices at runtime go through this proxy or this enterprise bus. So if that enterprise bus fails, all the microservices are dependent on it, all microservices will fail. If you find yourself where you want to design some type of a proxy mechanism or some transformation mechanism in a microservice world, you're better off by putting that in some type of a common library. What that means is that when you deploy that common library, you include it in your microservice code, that runs on an EC2 instance, let's say in the Amazon world, that runs on a machine that's dedicated for that specific microservice. Another microservice wants to use this type of a proxy or some transformation layer, they can include that library in their code, compile their code, deploy it to their instance in their machine where their microservice runs. So now you're separated. If one of these fails, or the machine or CPU or memory, it gets high on one of these machines, it doesn't impact another microservice. Yes, if the code written for this common library has a bug, you're impacting multiple microservices, but that should be covered in your unit testing and your automation testing. You should eliminate these big problems with the common libraries, but that's just the nature of using any common library you get within your company or you get out from outside. You buy a library, third-party library, you get some open source library. Another way of decentralizing this, for example, let's say you have a need for this type of a proxy. What you could do is have a little service that you compile and you have it sitting in front of your microservice. But that little service runs in front of your microservice. It's dedicated for your microservice. If another microservice needs this type of a functionality or proxying or transformation layer, what they do is they build their own proxy and they put it in front of their microservice. That's the way you decouple things. Maybe it doesn't feel a little natural here, where you may end up with some redundancy or cloning of code, but in microservice world, some level of redundancy is acceptable. Number five is, from DevOps point of view, automate everything you can. Basically, if you're trying to deploy a new type of database to your production environment and you need to support a new type of database, you need to automate that through DevOps. If you say, yes, I'm going to deploy this to production this time manually, I'll set it up, and then later you try to automate it the second time you try to deploy, that's never going to happen. Then you're always going to leave a little bit of manual work behind, and that manual work or that technical debt will accumulate over time. And what you find yourself after 2 years is that you have so many things in production or pre-production environments that are not automated. So you have to be 100% disciplined. If you're trying to get something from point A to point B, I mean from your local environment into your dev environment, into your int or QA environment, into stage and production, everything has to be done in an automated way. That's something that has to exist in the DevOps culture from day one. So that's number 5. Number 6. Number 6 is manually test before you try to automate. It's manually test before you try to automate. In my opinion, the person who is doing the automation should also be doing the QA work. It should be a single person. If you need 2 people doing QA and automation, then you hire 2 people. But you should not be splitting the work off. One person does the QA work, the other person does the automation. What it really means, what is manual testing? Manual testing is learning how your system works, finding all the little things that a human can figure out, not a machine. Once you know how certain things work, and if you want to reproduce that many and many times, then you automate those tests. If one person does the QA testing and the other person does the automation, then the automation person is really writing code without understanding how things work. You have to have a single person doing this, or you have to have very good knowledge transfer and knowledge sharing between the QA person doing the manual testing, which is really learning the system, understanding it, and then transferring that knowledge to a QA automation person. But I prefer if a single person does that, you will end up at better quality automated tests. Number 7, understand microservice dependencies. You start small at the beginning. You have 1 or 2 microservices, and then you get a dozen of microservices. And in your head, you can kind of paint a picture of dependencies between microservices and where these microservices are used in a customer flow or in some back-end processing, batch processing flow. But after a while, you end up with 20, 30, or 50, or 100 microservices. Now, how do you keep track of what's going on here? You really have to develop a microservices dependency analysis tool, which will paint a picture, kind of like a mind map of all microservices and how they call each other, and so you can see the dependencies. Once you paint this picture of microservice dependencies, you can see where the bottlenecks are. You can see where which microservice has a lot of calls going in, which microservice has a lot of calls going out, and most importantly, you can detect cyclic dependencies between microservices. This cyclic dependency could be from A to B back to A, or it could be a couple of levels deep and then coming back to A. So at the end of the day, you can manually draw this diagram of dependencies, but you can also develop a tool that will scan your configuration files statically, but it can also scan your production environment at runtime and figure out the dependency between microservices and paint this picture and draw a diagram for you, because this will help you determine weak spots in your architecture. It will give you ideas on what you can improve, and most importantly, when things break down and when you're troubleshooting a problem, it can help you figure out who is dependent on who, so that you can properly define what a severity 1 is, severity 2 is, and you can properly involve teams that are part of that flow that is failing in production. So those were the 7 items that are very important while working in Scrum teams and microservice architecture. I hope you found that useful. Thank you for watching. Don't forget to subscribe. If you like my videos, you can click the thumbs up button. If you don't like my videos, you can always click the thumbs down button, but I prefer if you click the thumbs up button. And I'll see you in the next episode. Keep geeking out.